How long would it really take to cross our galaxy? It sounds like a simple question, but the answer quickly reveals something uncomfortable about the scale of the universe. The Milky Way looks calm and familiar in the night sky, a soft band of light stretching above us. Yet that faint glow hides distances so large that even light itself needs 100,000 years to travel from one side to the other. To understand what crossing the galaxy means, we have to start with something familiar. Earth is small on cosmic scales, but it gives us a useful reference point. We measure our lives in hours and days, distances in kilometers, and travel times in minutes. Crossing an ocean takes hours. Crossing a continent takes less than a day. Even reaching orbit around Earth takes only minutes with modern rockets. But space changes everything. The first step away from Earth already stretches human intuition. The Moon is about 380,000 kilometers away. Light takes just over 1 second to travel that distance. Human spacecraft takes several days. That difference alone shows how quickly distances begin to grow beyond ordinary experience. The Sun is much farther away, about 150 million kilometers. Light reaches us in roughly 8 minutes. The fastest spacecraft ever built would need months to get there. Still, within the solar system, these distances remain manageable compared to what comes next. Our galaxy, the Milky Way, is a rotating disk of stars, gas, and dark matter. It contains hundreds of billions of stars, and our Sun is just one of them, orbiting quietly far from the center. The Milky Way is about 100,000 light-years across. That number is difficult to grasp, so it helps to think of what it actually means. A light-year is the distance light travels in 1 year, moving at nearly 300,000 kilometers per second. Even at that speed, crossing the galaxy takes 100,000 years. That is the fastest possible speed allowed by physics. But humans do not travel at the speed of light. So let's begin with familiar speeds and scale upward. A passenger airplane flies at about 900 kilometers per hour. If you could somehow fly an airplane through space without stopping, crossing the Milky Way would take more than 100 billion years. That is many times longer than the age of the universe itself. Clearly, airplanes are not built for space. So, let's move to rockets. The Saturn V rocket that carried astronauts to the Moon reached speeds around 40,000 kilometers per hour. At that velocity, crossing the galaxy would still take more than 2 billion years. Modern spacecraft can move faster once they leave Earth. The Parker Solar Probe, currently the fastest human-made object, reaches speeds of hundreds of thousands of kilometers per hour as it falls toward the Sun. Even at those extreme velocities, crossing the Milky Way would take hundreds of millions of years. The numbers barely change the outcome. The galaxy remains far beyond our reach. A more realistic example is Voyager 1. Launched in 1977, it is now traveling through interstellar space at about 17 kilometers per second. Voyager is moving faster than most spacecraft humans have ever built, yet it will take more than 70,000 years just to reach another star's neighborhood. To cross the entire galaxy at that speed would require millions of years. By that time, continents on Earth would have shifted. Species would appear and disappear. Civilizations would rise and vanish many times over. So, what if we imagine technology far beyond what we have today? Suppose a spacecraft could travel at 1% of the speed of light. That sounds incredibly fast. At that velocity, crossing the Milky Way would still take around 10 million years. Increase the speed again. At 10% of light speed, the journey would take roughly 1 million years. That is closer, but still unimaginably long compared to human history. Even advanced concepts like nuclear fusion engines or light sails, often discussed as future propulsion systems, would not solve the fundamental problem. The galaxy is simply too large. Eventually, we reach the ultimate limit, the speed of light itself. Light crosses the Milky Way in about 100,000 years. Nothing with mass can travel faster. Physics places a hard boundary on how quickly information or matter can move through space. This means that even in the most optimistic scenario allowed by known physics, crossing the galaxy is not a journey measured in lifetimes. It is measured in eras. At this point, it becomes clear that the real obstacle is not technology alone. The real obstacle is emptiness. Space is mostly empty. Stars are separated by enormous distances. If our solar system were reduced to the size of a coin, the nearest star would still be hundreds of kilometers away. Traveling through the galaxy would mean crossing vast regions with nothing in them. No planets, no stations, no natural stopping points. Just darkness and distance. This emptiness also changes how we think about movement. In movies, spacecraft jump between stars as if the galaxy were dense and crowded. In reality, most of a galactic journey would look almost identical for thousands of years. The stars would barely shift. The destination would remain distant for generations. There is one concept that slightly changes this picture: relativity. According to Einstein's theory, time passes differently for objects moving at high speeds. As a spacecraft approaches the speed of light, time slows down for those on board relative to observers at rest. This effect, called time dilation, means that a traveler moving near light speed might experience a shorter journey than observers back on Earth. From the traveler's perspective, crossing the galaxy could feel faster, but for the rest of the universe, the full time still passes. Tens of thousands of years would go by outside the spacecraft. Relativity does not eliminate distance. It only changes how time is experienced. So, why does science fiction make galactic travel look easy? The answer is storytelling. Movies and books compress scale because real distances would make stories impossible to tell within human lifetimes. Faster than light travel, hyperspace, or wormholes are narrative tools that bypass physical limits. They allow characters to explore the galaxy without waiting for thousands of years. Real astronomy offers a different perspective. Instead of imagining humans traveling freely across the galaxy, scientists study it through light. Telescopes allow us to observe regions thousands or millions of light years away without moving at all. In a sense, we already explore the galaxy and the universe by observing rather than traveling. When we look at distant stars, we see them as they were in the past. Light takes time to reach us, turning space into a record of history. The farther we look, the older the light becomes. Astronomy is not just about distance, it is about time. This idea changes the meaning of crossing the galaxy. Physically traveling from one side to the other may remain impossible for a very long time, but understanding the galaxy does not require crossing it. Through observation, we map its structure, measure its motion, and study its evolution. The Milky Way itself is not static. It rotates slowly. Our Sun completes one orbit around the galactic center roughly every 230 million years. Since the dinosaurs disappeared, the Sun has moved only a small fraction of that orbit. On galactic timescales, even stars move slowly. The galaxy also interacts with others. The Andromeda Galaxy, our nearest large neighbor, is moving toward us. In about 4 billion years, the two galaxies will begin to merge. Stars will shift into new orbits, and the structure of the Milky Way will change dramatically. Yet even during that collision, individual stars are unlikely to collide because the distances between them are so vast. Scale dominates everything. So, how long would it really take to cross the Milky Way? The honest answer depends on speed, but every realistic number is enormous. At human speeds, the journey takes longer than civilization has existed. At futuristic speeds, it still spans millions of years. Even light itself needs 100,000 years. The question reveals something deeper about our place in the universe. Humans evolved on a small world, within a small region of one galaxy among billions. Our sense of distance comes from walking, driving, and flying. The galaxy exists on a completely different scale, one that challenges intuition at every step. And yet, understanding this scale is one of the greatest achievements of science. Without leaving Earth, we have measured the size of the Milky Way, mapped its stars, and estimated how long light needs to cross it. We have learned that the galaxy is not a destination waiting to be crossed quickly, but a vast environment shaped by time and gravity. Perhaps one day technology will allow humanity to travel farther than we can imagine today. But even then, the galaxy will remain enormous. Crossing it will never be easy. Distance is built into the fabric of space itself. The night sky looks calm and close, but the truth is the opposite. Every point of light is separated by unimaginable emptiness. The Milky Way is not just large, it is a reminder that the universe operates on scales far beyond human experience. So the next time you look up and see that pale band of stars, remember what it represents. Not a path waiting to be crossed quickly, but a structure so vast that even light needs 100,000 years to make the journey. And that simple fact may be the clearest measure of how big our cosmic home really is.